This is linear algebra. We're gonna do metric operation. So there is some different multiplication in the metric operation. Let us start with the definition of metric. First, metric is gonna be usually number in the bracket, right? So M is number of row. This is number of row. This is number of column. So A metric is row 1 to M. Just first component they represent number of rows. So this one, look at the row I, gonna be I is row right there, guys. All the first component is I. Second is column represent the J, that's the second element. So when you write, for example, guys, this one, let's go to this one. When you see Aij, they say Aij, you represent I is row, J is column. Okay, that you're gonna address the entry of metric. Okay, for example, A, how many row they have? 1, 2, 3. So 3 times how many column? 1, 2, 3, 4. That's a 3 by 4 metric. So let's find the entry in the metric. Let's just start A11. So what is mean by the first row, first column? See, first row, first column. That's represent 1. Everything makes sense? Let's go another one. A32. Third row, second column. So third row, second column. That's represent 1, guys. Okay? That's how to find entry in the metric. First represent the number of rows, second is represent column, guys. Okay? Couple of terminology in matrix. We talk about matrix, that's the number of row, number of column. Let's say this one is I row, J column. What is mean by diagonal entry? Diagonal entry is gonna be I and J is the same. So I put the A11, A22, A33, A44, something like that. Row and column is the same. Diagonal metric is n by n. Let's say 2 by 2 matrix, 3 by 3 matrix, 4 by 4 matrix. Number of row, number of column is the same, guys. Okay, for example, I2 gonna be represent identity matrix. This one is, we see the 2 by 2 matrix. So diagonal gonna be 1, 0, 0, 1. Okay, diagonal entry gonna be 1, 1. Everything is 0 and 0, guys. Okay. Another one is, guys, let's talking about I4. You can see that 4 by 4 metric. So you're gonna see 4 by 4 metric, but diagonal is all 1. A11, A22, A33, A441, everything is 0, guys. That's identity metric, guys, okay? Zero metric is, it depends on the size, but I put the, how many here, I say here is a 3 by 1 metric. That's the zero metric. All the entry gonna be 0. We're gonna say zero metric. All right. Is I want to define addition and subtraction. First, very importantly, you have to remember right here, guys, it's same size. If you have a different size, you can add, you cannot sub. You cannot add, you cannot subtract. So let's go to first one, guys. Here, what is the size of a metric is? 3. This metric is first row, second, 1, 2 row, 1, 2, 3. 3 by 2 by 3 metric, right? How about this one? This one gonna be 2 by 3 metric. Size exactly same. How about C? 2 row, 2 column, 2 by 2 metric. Oh, A plus B, can you define? Yes, can you define? How can define A plus B? First component, okay? 4 plus 1, 0 plus 1, 5 plus 1, -1 plus 3, 3 plus 5, 2 plus 7. That's why you define the addition of two metric. That's gonna be 5, 1, 6, 2, 8, 9. Everything makes sense? Okay. How about A minus B? Same thing. A size of A, size of B, same size. Subtract 4 minus 1, 0 minus 1, 5 minus 1, -1 minus 3, 3 minus 5, 2 minus 7. So this is gonna be 3, -1, 4, -4, -2, -5. That's how to define metric, guys. Okay, addition of metric, subtraction of a metric, guys. All right. How about A plus C? Metric A has a size 2 by 3. Metric C has 2 by 2. So undefined, guys. I'm gonna make sure this one is gonna be, guys. This is undefined because size of A is 2 by 3. Size of C is 2 by 2. Size is not same. So you cannot define addition or subtraction of two metrics, guys. Next one is scalar multiplication. Scalar meaning is number, guys, any number. So A matrix size doesn't matter when you do the scalar multiplication. 2A. So how can you do the 2A? Here is a B vector right there, guys. All the B vector. Each entry gonna U times T. That's you're gonna do it. 2 times 1, 2 times 1, 2 times 1. Let's go to second law. 2 times every element entries. 2 times 2 times 3, 2 times 5, 2 times 7. So this one gonna be 2, 2, 2, 6, 10, 14. That's how to do scalar multiplication, guys. Let's try this one. A minus 2b. What is A? You find A. 405, -132, minus 2b. 2, 2, 2, 6, 10, 14. So they are the same size, right? Size of A, 2 times 3. Size of B, size of 2b is 2 times 3. Same size, so you can do the subtraction. So let's do the subtraction right here, guys. Each element, 4 minus 2, that's 2. 0 minus 2 minus 2. 5 minus 2 is 3. -1 minus 6, -7. 3 minus 10, -7. 2 minus 14, -12. Okay, that's how you're gonna do this subtraction, guys, all right? Okay, so this is a property of addition and scalar multiplication. You cannot do commute, which meaning is you're gonna start A plus B or B plus A. It doesn't matter, guys, when you do addition. Also, association in the math terminology, A plus B plus C gonna be A, this one first, and you're gonna do A later, okay? Metric A plus zero metric, of course, this one is A because you add zero, still same thing. Scalar multiplication, you can distribute. So scalar multiplication A plus scalar multiplication B is fine. Scalar multiplication add together, do the scalar multiplication later, but this one is also you can distribute the metric. Last one is this one first, scalar multiplication, this one first, and all gonna be later, or scalar multiplication first, you're gonna times metric is later, exactly the same. Let's practice sum and scalar multiplication of matrix, guys. You can pause the video and then you can do your own, guys. All right? Okay. So let's do this one. Before you do addition or subtraction, check the size of each metric, guys. A gonna be metric A is size first, second, third row, three row, three times, one, two column. How about metric B? Three times two. How about C? Two times one. How about D? Two times one. You can do addition, subtraction with metric A and B, but not A and C, guys, okay? So negative 2A, negative 2A, 2, 1, 0, 5, negative 3 and 6, plus 3, that's gonna be negative 3, 4, 0, 2, 1, negative 1. So what do you have here, guys? Little space times the scalar multiplication to the each element, right? So negative 4, negative 2, 0, negative 10, 6, negative 12, plus negative 9, 12, 0, 6, 3, negative 3. Same size. You can add each entries, negative 13, 10, 0, negative 4, oh, 6, 3, guys, 9, and negative. What happened here, guys? Okay. Negative 12, negative 15. Everyone got the same thing? That's how to do it. Second is 5C minus D. Check the C and D size, 2, 1, 2, 1, right? So we can do it, guys. We can do it, same size. So let's do it here. 5 times 2 and 3 minus D, 1 and 1. 5. 5 times 2 is 10. 5 times 3 times 15 minus 1 and 1. So this one is 10 minus 1 is 9. 15 minus 1 is 14. So you can do this one, right? But how about the next one? What is the size B of a metric? You say this is 3 times 2. How about C? 2 times 2. So we cannot do it undefined. Everyone make sense? All right.